Hello my dear students, welcome to my YouTube channel. So this video is the part 2 of general trend of different properties in the period and the groups. See, the one video that I have uploaded consists of some atomic trends which varies along a period and down the group. And as an exam point of view, like for a NEET, for the CET, yes, these atomic trends play a very important role. Okay, the same thing I have told you even in the first video. So here the remaining in a part 2, I have taken around 6 to 7 atomic trends and how they're going to vary along a period and down the group. Let us see. Okay, so now first property that I have taken over here is metallic character. Okay, this I think I have repeated in that video also in the part 1, but still I have taken. So what happens along a period for the metallic property and down the group? Okay, so as we all know, metals are the good conductor of heat and electricity. Why? Because they consist of free electrons. As the more electrons available in a metals, obviously their metallic character increases, or the ability to donate the electron increases. Agree? So here what happens along a period, see, as you all know, one trend you had to keep in your mind, that is the atomic radius. This trend compulsory you had to keep in your mind. So as you all know, what happens to the atomic radius along a period? It decreases. Okay, so what happens down the group to the atomic radius? Yes, so it increases. Why? Even I have explained this in the previous video. See, as we go along a period, what happens? The electrons will add to the same shell. So the distance between the nucleus and the outermost electron will not increase. Instead, the Z effective increases, the effective nuclear charge increases. So the size goes on shrinking. Okay, so here the metallic character depends on the size of an atom. Okay, so along a period, what happens to the metallic radius? Decreases. Why it decreases? Because the atomic radius also decreases. As the atomic radius decreases, even the outermost electron are strongly held with the nucleus, dear students. Okay, so if the outermost electron are strongly held, obviously how it can donate electron freely? So donation of an electron decreases. So obviously metallic character along a period decreases. Okay. Similarly, as we go down the group, the metallic character increases. Why? So as we know, as we go down the group, the atomic radius increases. So the distance between the center of the nucleus and the outermost electron increases. So this outermost electron are very free. So availability of a free electron means it can donate electron. Okay, so obviously metallic character, what happens? It increases down the group. So I have given you the relation of this metallic character with the atomic radius. That's how you had to relate. So this atomic radius trend you had to keep in your mind. So many trends depends on that property. That's why. Okay, yeah, I hope it is clear. Now let us enter into the next property, that is oxidizing nature. Dear students, before going to that, you should know what you mean by oxidizing nature. And oxidizing nature is the one which accepts the electron. Okay, which attracts the or which accepts, which gains the electron. Okay, so dear students, along a period, what happens to the oxidizing nature? It increases. Why it increases, dear students? As we all know, along a period, the electronegativity increases. What do you mean by electronegativity? It's a capacity to attract the shared pair of electrons towards itself. Okay. Oxidizing nature means what? It's a property of accepting the electron. So obviously, along a period, the oxidizing nature increases. The capacity to accept the electron increases. Why? Because again, I will relate that with a property, that is atomic radius. size decreases, so the incoming electron will find more attraction. Obviously the oxidizing nature also increases. Okay, so what happens down the group, dear students? Down the group, atomic radius increases, so the distance between the nucleus and the outermost electron increases. Okay, instead of attracting the electron, instead of accepting the electron, what happens? The oxidizing nature goes on decreasing. So that's a second property. Okay, come to third one. So it's a vice versa. Okay, so come to the third one, reducing nature. What do you mean by reducing nature? Reducing nature is a capacity to lose the electrons. Okay, so see, oxidizing nature and the reducing nature are inversely proportional. This is how you can relate. Okay, so as we go along a period, the capacity to lose the electron, what happens to your students? It decreases because the electrons are strongly held. Why? Because the atomic radius decreases. Okay, so along a period it decreases, down the group it increases. Do remember the oxidizing nature trend, and the reverse of that one will be a reducing nature. This is how you should relate and you should learn. So the next property is called screening effect, which can also be known as a shielding effect. What do you mean by screening effect? See, here you could see we have a nucleus, okay, and we have a number of shells like this. So what happens? Here is a valency electron. Here we have a nucleus, dear student. So in between there exists a number of electrons, right? So as the number of electrons increases, the what I can say, the connection, in a simple word, the attraction of this nucleus to the outermost electron, what happens, will decrease because these electrons will act as a shielders or screeners. Okay, so instead of attraction, what happens here? Electron repulsion starts happening. Okay, so that is what we're going to call it as a screening effect. Now what happens to the screening or a shielding effect? Along a period it decreases. Okay, along a period the screening effect decreases, whereas down the group screening effect increases. Again, dear students, why along a period screening effect decreases? Again, the atomic radii decreases along a period. Okay, so the distance between the nucleus and the outermost electron is also less. Okay, here what happens? The attraction is dominating than the repulsion over here because of the small size. Okay, the screening effect along period it decreases, down the group it increases because the number of shells increases. As we go down the group, the number of shells increases, the size increases, so that the outermost electron are free and the number of electrons will increase over here. What happens? The number of screeners increases, so the distance or the attraction between the outermost electron and the nucleus will be very less because here they're going to act as a good screeners. Okay, so along a period decreases, down the group it increases. Okay, now the next property is effective nuclear charge. What do you mean by effective nuclear charge? We're going to call it as a Z effective as well. Okay, effective nuclear charge is nothing but the attraction between the center of the nucleus to the outermost electron. Okay, so quite simple. In a simple word, if you want me to tell, so here how much this nucleus what does the nucleus consist of? Protons and neutrons. So how much this positively charged nucleus will attract the electron towards itself, will strongly hold the electron towards itself. That is what the Z effective. So quite simple, dear students. Again, this atomic radius is taken into consideration. So as we go along a period, what happens? The atomic radius decreases, the size decreases, so the outermost electron is strongly held with a nucleus. So the attraction between the nucleus and the outermost electron is what? Is more. Okay, and the Z effective is also more. It increases. Why it increases? Again, the electrons will enter into the same shell, dear students, where along a period. Okay, so obviously here is the nucleus, here is the nucleus, and here what we have, the outermost or the electrons are entering into the same shell. So the distance is not increasing here. Instead, what is happening, the attraction is increasing, so that the size shrinks, or the Z effective also increases. So down the group, what happens here, they have given it as a constant. So down the group, what happens, the number of shells increases. Okay, as the number of shells increases, the distance between the nucleus and the outermost electron also increases. Up to certain level, yes, the attraction increases, Z effective increases. But as we go down the group, here what happens, the size goes on increasing. So the nucleus will not find more attraction towards the outermost electron, so that the effective nuclear charge remains constant or it decreases. Okay, now come to the next concept, that is density. What is density? The general definition that we know is a mass by volume. Okay, along a period, what happens? Obviously atomic number increases, yes. Okay, so atomic number increases, the number of electron increases, mass increases, yes, obviously density increases. So up to group 3, yes, there is a gradual increase, but as we go along a period, there is a slight decrease in the what I can say, density. So now come to the density of down the group, it increases because the number of shell increases, the mass increases. Okay, so that's why down the group the density also increases, the number of electron increases. Okay, so last one property, that is electropositivity. So how you can remember electropositivity is, if you know the trend of electronegativity, then you can remember electropositivity very easily. Electropositivity character means what? It's a capacity to donate electrons, to give out the electrons. Okay, so obviously along a period, the atomic radii or the size decreases. So obviously the electrons are strongly held. Okay, if the electrons are strongly held, obviously it gets difficult to give out the electrons, it gets difficult to donate the electrons. So electropositivity along a period decreases. As we go down the group, the electropositivity increases. Why it increases? Because the number of shell increases, the size increases, the radius increases, so the outermost electron are free, so that its a capacity to donate electron also increases. So the electropositivity increases. Okay, so these are the some trend I have taken in a part 2 of this video. Okay, as I told, exam point of view, these are very important. Please go through all the trends once or twice or thrice. If you're able to relate, means if you're able to relate each property with the atomic radius, then it gets very easy to memorize or to remember all the trends. Okay, I hope you find this video useful. So there will be another video of the same concept, part 3. Okay, shortly I'll going to upload that video. I hope you find this video useful. Thank you so much.